Hello students and welcome to this video. In our last video, we looked at derivatives of implicit functions. And you're going to be thinking, okay, now we're going to inverse trig functions. It feels like this is super different than what we learned last time. And like, how are you going to keep adding on to this, Mr. Hernandez? But stay with it because in this video, we're going to be looking at inverse trig functions and how they're super related to implicit derivatives. So let's get started. All right, as I said, we're going to be looking at these trig derivatives, and we know cosine, sine, tangent, we know all of these derivatives, right? But what about their inverse trig derivatives? Okay, so we're going to be looking here at y is equal to the inverse tangent of x, right? So we know what the derivative of tangent of x is, but we want to think about some of these things in a more general sense. So let's this is going to be my preferred method, and this is what I would call like the discovery method about these inverse trig functions. And it's really, really nice to see how they're going to kind of get set up in this long way. But in our next video, you can kind of start to memorize what these inverse trig derivatives are. So let's just think, all right, what does x represent in this equation? Well, what I want to think is, in this sense, we're talking about side lengths, okay? So x represents side lengths. So x is going to represent side lengths, a ratio of side lengths. So if we have tangent, it's opposite over adjacent. So a ratio of side lengths. All right, so what does y represent? So if x is going to be the ratio of side lengths, then we know that y is going to be that angle, right? So the inverse trig derivative, or the inverse trig function, is going to get us the actual degree measurement, the radian measurement, that angle. So y represents the angle. All right, so when I'm looking at this and I'm going to say, all right, write the inverse relationship here. So in order to find the inverse relationship here, right, all we end up doing is say, all right, our inverse relationship is just going to be the tangent of y equals x, because you end up just taking the tangent of both sides, right? So if I want to solve for the x, the inverse relationship, I just take the tangent of this part and it just becomes, all right, that is going to be tangent of y equals x, right? Well, we know how to take this derivative. So we know the derivative of tangent. So I want to differentiate both sides of the equation, and we're going to just end up solving back for dy dx here. All right. So in order to take the derivative, and this is where implicit derivatives are going to come in. So we're going to take the tangent, the derivative of tangent of y. So that's going to be secant squared of y. And since in our last video, we learned about implicit differentiation, we need a dy dx dropped right after that because of the chain rule. And then the derivative of x is just going to be 1 dx dx because of the chain rule, but that's just another 1, all right? So we know that dy dx now is going to be 1 over secant squared of y. Okay. Now we have this nice little triangle over here, right? And what I want to do is kind of display what we have for the tangent of y equals to x. All right, so the tangent of our angle is going to be opposite over adjacent. So if we were to solve for this missing side, what would that say? Well, we could say that we have x squared plus 1 squared is equal to that missing side. Okay, so equals that question mark. So what is this question mark equal to? Well, that is just going to be squared. So if I take the square root of this, this is going to be the square root of x squared plus 1. And that's just a Pythagorean theorem at its finest, right? So very intuitive. We know, okay, we have all these squares. All right, so x squared plus 1 squared. All right, the square root of the hypotenuse is going to get us the square of the sum of both sides. Okay, so now we want to keep thinking about this. Using that little triangle over there, we have cosine of y and secant of y. Okay, so what is cosine? Well, cosine is going to be adjacent over the hypotenuse. So cosine of y is the adjacent divided by the hypotenuse, so the square root of 1 plus x squared. And then secant of y is just going to be the reciprocal of that. So secant of y is just going to be, secant of y is just going to be the square root of 1 plus x squared. All right, so now we're going to come up and we're going to plug this in to our equation that we found all the way up here, 1 over secant squared y. All right, so we know dy dx is going to be equal to 1 over secant squared y. right? And what I want to do with that information is I know that secant of y is this. So if I find secant squared of y, I'm just going to square both, right? So it's pretty intuitive. dy dx is going to be equal to that function squared. So it's going to say 1 over the square root of 1 plus x squared squared. So it's just going to say 1 plus x squared. So dy dx, which is what we were looking for, the derivative of the inverse tangent, is equal to 1 over 1 plus x squared. And all we really had to do was know, okay, what is the inverse relationship, right? We know that from algebra 1. And then we just find some Pythagorean identities, and we know the ratios thanks to SOHCAHTOA. And we just put all these pieces of knowledge together. And yeah, it's a little bit long, but it's super intuitive. This is something that I can do quickly on a test, right? So with this idea, I want us to keep in mind this triangle over here. And as you guys are looking over there at that triangle, I want you to keep in mind, like, okay, can I draw this triangle? What is the relationship? Is it opposite over adjacent? Is it opposite over hypotenuse? Is it adjacent over the hypotenuse, or something even more different than that? How can I write all these ratios down? Do I know these ratios thanks to SOHCAHTOA? Yes, you guys do. All right. And I want you to keep that in mind, and following that step-by-step breakdown, I want you to pause this video and see if you can complete parts 2 and 3 here, finding the inverse relationship derivative of inverse sine and inverse cosine. Are y'all able to figure that out? Of course, I'm going to solve this out here in the video, but go ahead, see if you can pause this video and fill out all of these ratios using implicit derivatives, just like we learned in our last video, to solve for these two derivatives, right? All right, so number 2, we're going to start, okay, what is the inverse relationship here? We know that is going to say x equals sine y, okay? We want to differentiate both sides. So that's going to say 1 equals cosine of y dy dx, okay? And I want to solve that for dy dx, so I'm going to divide by cosine of y, okay? So that dy dx is going to be 1 divided by cosine of y, okay? Keeping in mind that y is the angle, okay? So since y is our angle here, we know that we have the hypotenuse equal to 1. So x squared plus something squared is going to get us 1 squared, okay? And if we want to figure out for that something squared, we are going to take the square root. So that missing side is going to be equal to the square root of 1 minus x squared. So this missing side is 1 minus x squared. So like I said, pretty intuitive. Just keep solving for these missing sides. So now we know the cosine of our angle is the adjacent side, which we just found, over our hypotenuse. So cosine of our angle is the square root of 1 minus x squared over our hypotenuse of 1. So square root of 1 minus x squared. That's it. All right, so now let's think back all the way up here where we found this 1 over cosine y. So the derivative, d dx, the inverse sine of x is going to be equal to 1 over, okay, so we have cosine of y, so that is, we just figured out cosine of y is the square root of 1 minus x squared. And that's it. We have discovered that derivative, the derivative of inverse sine of y is 1 over square root of 1 minus x squared. So we're just plugging in a few things and we're good to go there, okay? And now we're going to move into cosine. Okay, so write this inverse equation, differentiate both sides, and solve for dy dx. Okay, so again, we know that x equals cosine of y, right? Just cosine of both sides, and we get x equals cosine of y. Okay, so let's take that derivative, and we're going to get 1 equals negative sine of y, and drop a dy dx because of implicit differentiation. All right, so let's solve for dy dx now. So dy dx is going to be equal to 1, or I guess we can move that negative up there into the numerator, sine y. Okay, so we know cosine of y is adjacent over the hypotenuse. So cosine of y is x over 1. So we have x and we have 1 here. All right. Now we want to figure out what is the missing side. We know the missing side squared plus x squared is going to get us 1. And if we solve for the question mark, that missing side, our question mark is going to be equal to 1 minus x squared, the square root of that. And now we know the sine of y, which is what we were trying to solve for here. We know that the sine of y is going to be the square root of 1 minus x squared. Pretty similar to what we had in our last one. So now what we look at is, all right, we're looking here dy dx. All right, so making a substitution, we know that dy dx is -1 over sine y, and we have now figured out what is sine of y equal to. So we can say dy dx is equal to -1 over the square root of 1 minus x squared. So this is equal to the derivative of inverse cosine of x. And that is going to be an intuitive approach to figuring out these derivatives of the inverse trig functions. In our next lesson, I'm going to show you, if you memorize these, how it can kind of help a little bit. Some of y'all might enjoy to memorize these. I personally do not. I pretty much go through this long method every single time because the triangle is pretty quick to solve, and all of these ratios are very straightforward. But what if we were trying to find another chain rule inside of this? So the derivative of inverse cosine of 2x or 2x squared or something like that. Well, what would we do and how do we label that? So let's come back together in our next video and I'll be able to help you with that. I'm Mr. Hernandez and this is Mr. Hernandez Teaches.